This is the notes for 2.3 scale factor. So we've been talking about this a lot already this unit, but just a reminder, here's our concrete definition. Scale factor is a number used to multiply the lengths of a figure to stretch or shrink, meaning it got larger. That's an enlargement. I times it by something greater than 1. And if it reduces, that means it gets smaller. I times it by something between 0 and 1. So I times it by either a fraction or a decimal that was less than 1. That'll make my figure smaller. The scale factor of two get similar figures is given by a ratio that compares my corresponding sides. Okay, so as a reminder, corresponding means that this side matches up with that side in my smaller figure. Or my side length BC matches with that smaller side length right there. And then my bottom, A to C, matches up with that smaller side length right there. So we talked about that the very first day of notes. So make sure for all your problems today, your scale factor, when you write it as a fraction, it's a ratio between the sides that correspond. Okay. In this example, it says my scale factor is 1/2 because you'll notice my shape from the original to my image, the new one, it got smaller. If I had taken it times 2, that would have got me from here to make it bigger. Okay. Since I got smaller, I can compare, and I know I should end up with a fraction at the end. So for example, this length here was 3. This length here, they approximated to be 1.5. And so my scale factor, 1.5 over 3, is the same as 1 over 2. Okay, you'll notice they said the image over the original. You can write that bigger over here if that's going to help you. Or go ahead and just highlight it in that box. Okay. But the other very important idea for today is once I find my corresponding sides, the ones that match up, make sure to find your scale factor. You do the new one over the original. So in this case, I knew I was supposed to get smaller, which was 1/2. So I put my new side of 1 over my original side of 2. Okay. Other big idea is that area is not the same as scale factor. So the lengths of the similar figure will stretch or shrink by my scale factor, and the areas of the figure will not change in quite the same way. So for example, in this picture, my original shape had a scale factor of 2. So you'll notice the length on the bottom got taken times 2, but then the length on the side also got taken times 2. So that means my area increased by a factor of 4. The scale factor was 2, so that happened to both sides, and it made my area have a factor of 4. Okay, same thing here. So my 2 into my 6, you'll notice it happened 3 times. So I went ahead, so 2 times 3 made 6. And then same thing here, 3 times 3 made 9. But when I get done, my area is not just times 3. My area was times 3 times 3. So my area is actually 9 times larger. So the other note I would make to myself is if you're finding the area, it's the scale factor times my scale factor. Okay. You'll see it as a square right here. So that tells me I did a number times a number. So whatever I do to one side length for scale factor, I did to the other side length. And so the area was the scale factor times the scale factor. All right, so let's try some examples here. In my picture, you'll notice they're all facing different directions. So my first step is actually to turn them so they're all facing the right way. So I'm going to go ahead and leave this one with that right hand in the bottom left-hand corner. So if I was to rotate, A is my right angle, the long length is C, and the short length there was 3, and my diagonal was 5. Same thing with this one. I'm going to go ahead and turn it right side up so it looks like the other ones. So H was in the corner, J was the longer side, and then H to I was my shorter side of 9. The diagonal part was 15. Just to make it a little easier there to see what's matching up. Okay, so my scale factor from ABC, this triangle right here, to DEF, I'm noticing it's getting larger. I want to find two corresponding sides that match up. So let's say D to F and A to C. Those are the same corresponding sides. My scale factor is the image over the original. So my image is 8, the original one is 4. My scale factor is times 2. You can also compare the other sides. So A to B corresponds with D to E. So my image is 6, my original is 3. That's still a scale factor of times 2. Okay. Last one we can double check. 5 corresponds to 10. My image is 10, my original is 5. So yep, all those have the same scale factor of times 2. We're making the assumption here that the angles are already the same, so we know these are similar figures because my scale factor is times 2 and the angles were the same. If I was to go the opposite direction though, from DEF to ABC, you'll notice that direction there, I'm going from the big one to the small one, then they're going to be flipped. So this time my new one is 3 where the original side was 6. Or the new side is 4 where the original side is 8. Same thing with 5 and 10. So if my scale factor from small to big, that's ABC to DEF, is times 2, it means my scale factor from DEF big to small ABC should be times by 1/2. Okay? I don't say divide by 2, I always say times by. So to make it smaller, it's like timesing by a fraction. Okay. Let's try that same thing now, but with ABC to HIJ. So my orange color, AC, corresponds to HJ, which is 12. My image is 12. My new was 4. So my scale factor is times 3. It's getting bigger. But let's double check, make sure those other sides work out to be the same. So side 3 corresponds to side 9. The new is 9. The original was 3. 9 divided by 3 is also a scale factor of 3. And then my diagonal side of 15, that matches up to 5. And yes, 15 new, original 5. This picture is getting 3 times bigger. When I redrew it, it doesn't quite look like that, but if you look from this one to this one, you can tell it's about times 3. It's getting larger. If I was to go the opposite direction, now it should get smaller. So from HIJ to smaller ABC, it's the opposite. So from 3 to 9, right? From 15 to 5, original is 5 to 15. And then from 12 to 4, my new is 4, the original is 12. All of those fractions simplify to be 1/3. Okay, so again, I never say divide by 3. I say I times by 1/3. This is a number less than 1, so when I multiply by something less than 1, that's what makes it smaller. You'll notice it's the reciprocal, so I flip this to become a fraction 1/3.